Hello everyone. In this video we'll be discussing about operator overloading. So let's first try to understand what the code is that I have written down and why we would need to overload an operator. So for this example I have a class A in which there is a private data member called A again. And so I'm able to show the value of A and also set the value of A. What I'm doing here is I'm creating two objects, setting each other's values. And what I want to do is simply I want to perform this operation wherein a new object C will be initialized simply by A minus B, in which A minus B would actually involve that for each of these particular objects, their data member values is difference. So again, what I want is uh, basically C dot A should be equal to A dot A minus B dot A. But we cannot directly do this since A is a private data member. And so what I want to do is I want to allow the minus operator to actually work directly on the object itself so that the code is more readable to us rather than having it entirely abstracted. Although the functioning will be abstracted, this becomes more intuitive for the user. So how do we actually proceed to code this? So that is done in a similar syntax wherein we overload or we write a function called operator minus, which returns an object of in this case it returns an object of type A or class A, and it takes in an argument again which is an object of class A. So what this actually does is whenever we write A minus B, what it will do is it will work on the object A, the first object which we give in this expression, and then it will equate it to A dot operator minus of B. So it is in short calling a function, a member function of class of the object A. So in our case, our this pointer will actually point to our object A, and our obj will be equal to B. Right. So now let's see what we have actually written in this function. So what I'm doing here is I'm creating an intermediate object, and then since this is a member function itself, we can directly access the private data members. So for that intermediate, I'm assigning the value to A, or rather this arrow A minus obj's A, which is what we want from our minus operator, and then I'm returning that intermediate created object. Simple. Again, what we want to achieve is the functionality of this, wherein we want to subtract the values of the data member A present in this object and this object. Hence, what I'm doing is I'm creating an intermediate object wherein its A's value will be equal to the difference of those two values, and I'm returning that value. So let's see how it compiles. So what I've done, A has the value of 10, B has the value of 20. So C will have the value of 10 minus 20, which is minus 10, which is being shown as provided. Also, what I'm doing at the end is I'm printing out the difference between 1 and 2. So 1 minus 2 is again minus 1. Why I've done this is to show that we are not actually modifying the functionality of the minus function, minus operator itself. All we are doing is we are adding to its functionality. So we just added that the minus operator can also work on this object depending on whatever operations we perform within this function. It does not actually change the original or the various meanings that this operator itself could have. Now, this was the case in which we are operating between two objects of the same type. So both A and B are of the type of class A. Now what happens if I'm trying to actually operate between two objects which are not of the same class? So here in such cases we'll use a friend function. For example, Here I'm doing c dot show, which I do not want to do. I want to be able to directly use my cout operator to use an object of class A. So what such an expression could look like is cout, the insertion operator C. So how this how let's actually break down what we have actually written in line 36. So we have an operator. It is a binary operator since it operates on two operands. The first operand is an object of the ostream class called cout, and the second operand in our case is going to be an object of class A. Now, since we cannot actually go and change or write in the definition of the ostream class itself to include or to change the behavior of this operator function, what we do is we define a friend class. Remember that a friend class allows you to access the private data members. So in this case, we want to access the private data members of the type A. So what we do, we define a friend called which returns an ostream type object called operator so and so. It could be insertion for insertion and extraction for extraction, which takes two arguments, which is both the object of the ostream class and that of the A class which we have. Then what I do in its definition is simply write out whatever I want to actually print to my console. So in this case, whatever ostream object I get, using that I want to show the data member A of this object obj. So that's what I'm doing over here. So out will write to my console obj.a, and I'll return that particular ostream object behind. So again, this would also get broken down into operator cout comma c. So let's actually try and run that code first. So we see that -1 is getting printed directly. So -10 from here. And since I'm not printing any endl over here, there is no new line character followed by -1. So we can either do that or use the cout operator directly, cout, extraction operator, and c. And since we have defined this function, this friend function, which will be able to act on both of them, its functionality will be implemented using this. So this should also give us a similar result. Right. We can now add our manipulator endl. Right. So we get the value -10, and again the if I try to print cout hello, we see that hello is actually getting printed, meaning that the original definition or original way or original operation that this operator performs is not actually changed. We are adding just additional implementations to satisfy our manual needs. So this is how you can overload an operator to act between two objects of the same class or objects of different classes different classes as well. So this has been all about operator overloading. Thank you.